Okay, so like we're able to establish that this one was oxidation. Then this was where some persons were still trying to come to terms with before we went off. So some persons were of the opinion that we link this to hydrogen chloride. That is, this goes to this, right? Why some persons don't know which category or where do we even link it to. So for the benefit of those persons, this next one, that is this, is also from here, not to hydrogen chloride.
Why?
Okay, good. This is going to take us to the next explanation of redox reaction based on oxidation number. Remember, we said we can define it based on hydrogen transfer, based on oxygen transfer, and then another criteria which could be used is based on the oxidation number. Now, I will come back to this while we define that aspect first. So in terms of oxidation, that is oxidation number. Based on oxidation number, oxidation has to do with increase in oxidation number. Oxidation has to do with increase in oxidation number, while reduction has to do with a decrease in oxidation number. Oxidation has to do with an increase in oxidation number, while reduction has to do with a decrease in oxidation number. Is that okay? Did we get that, please? I believe you have. So now let's now look at the oxidation in terms of oxidation number. Now, oxidation is the increase in oxidation number, or it has to do with increase in oxidation number. That is for oxidation. That is, there's an increase in the oxidation number of the species. While reduction has to do with a decrease in the oxidation number. Is that okay now? Can I move on now? Mr. Obie, can you hear me?
I can hear you. Can move on.
Okay. So next is now is the issue now is, how do I know that this one was linked to this? And how do I know that this undergoes reduction or oxidation now? Let's find, look, I will underline this Fe and also underline Fe here. To bring out this one, this is FeCl3. And this is FeCl2. I believe maybe you must have taught your students how to write formula of compounds, or you should know how to write formula of compound. Formula of compound are always written from valencies. This FeCl3, there's an invisible one here which you are not seeing. There's also an invisible one here. So I want to take this back. This is meant to be like this. That is Fe3 plus, and this is Cl minus. Why this is Fe2 plus Cl minus. So the oxidation number or the valency of chlorine here is +1 or -1. Why this is also -1. Then the valency of this Fe here is +3, and this is +2. So if you consider this FeCl3, the oxidation number of Fe here in this compound, that is in this compound, is +3. So Fe here is +3. Fe here is +2. So what has happened to the oxidation number of this compound, of Fe in this compound? Oxidation number of Fe, which is your ion, has reduced from 3 to 2. So is that oxidation or reduction?
Reduction.
Reduction. So this has undergone reduction. Any question now? Then we can now see that this is my reducing agent and this is my oxidizing agent. So the role of H2 here, H2S, which is the hydrogen sulfide, in this equation is it is acting as a reducing agent, while this is acting as the oxidizing agent. Any question?
No, from my end.
So, because we are looking at the third definition of redox reaction in terms of oxidation number, let us look at this equation. 2Fe, 2 plus Cl2, give me 2Fe, 3 plus 2Cl minus. Did you get that? Fe2 plus Cl2
Is this one?
plus Cl minus. Is this equation balanced? Mr. Ovier. I can see you from here. Oh, Mr. Okay, I'm seeing two Ovier, so I really know which of them. But the one with the mic that is mute, if you can unmute your mic, just tell us, is this equation balanced so we can move on? Okay.
It's balanced now.
Yes, it's balanced. Now, in this question, this was one particular question from White. They said, identify the reducing agent in the above equation. Identify the reducing agent in the above equation. So how do we go about that? If you look at the equation now, there's no hydrogen, neither there's no oxygen here for us to be able to point which of them is undergoing reduction or which of them is undergoing oxidation. But there's also a clue to help us out. Now, this time around, I will be able to identify
number
based on oxidation number. So I'll write under here ON. ON means oxidation number. You can write it out in full, but I'm only just writing it under here. So oxidation number, Fe here is +2 because of this you are seeing here. Oxidation number of a free element is always 0. So this is 0. This is +3, and this is -1. Any question? So if you look at this now, this to this, what has taken place in terms of the oxidation number? The oxidation number has increased from 2 to 3. So that is what? Is it oxidation or reduction? This is oxidation.
What is that? Substance oxidizes a reducing agent, and substance reduces oxidizing agent. Okay. So from that, sorry, let me see your board. My laptop is still off now.
Okay. This Fe.
How come there? I'm coming, sorry. From your Fe, you have 2+.
Yes.
Which is the valency.
Yes.
And from the definition of oxidation, it is +2 here.
Yes.
Then at the product side, it has increased to +3.
Yes.
That shows that oxidation has occurred.
Yes.
Then here we see chlorine 0 here.
Yes.
From 0 -1. That means oxidation number reduced. So that means that
this is
reduction occurs there.
Reduction, yes.
Reduction.
Yes. So this Fe now is my reducing agent. while this is my oxidizing agent. So the species oxidized is Fe2. Species that undergo reduction is Cl2. The reducing agent, Fe2 plus, oxidizing agent is Cl2, that's chlorine gas. Any question? Okay. Can I continue, please?
Yes.
I'm cleaning this up. Anybody here? No, nobody? Okay. So I think I have one jump question here. Let us see, and then just look at it together. In the reaction above, this is the reaction. S2, O3, 2 minus plus I2, giving S4, O6, 2 minus plus 2I. So the question here is this. Or in the reaction above, the oxidizing agent is, what is the oxidizing agent in this reaction? The oxidizing
SO230 reducing agent.
Okay. How do I have is the equation balanced, please?
While iodine is the oxidizing agent.
Is the equation balanced?
No.
It doesn't look as if it's balanced. So we should put 2 here.
Yes.
Okay. So if you check here now,
Yes.
what?
It's balanced.
Minus 1, and this is 0. So what has taken place here? From my
Gain of electron.
Oxidation number changes from -1 to 0. Is that an increase or a decrease?
An increase.
Okay, so this is oxidation. Then obviously this becomes my reduction. So this is my OA.
Wait.
This is my RA. So the question was, in the reaction
Loss of electron
above, the oxidizing agent is, so the answer should be S2O3. S2O3. Any question, please?
That's a good question.
You have a
Because
question?
most of the group 7 elements,
Yes.
they play major role as oxidizing agents.
Yes.
So it's a good question.
Okay. So I think let's move on now. If I have another one, I'll just quickly throw it into this. Then lastly, another term for defining oxidation is based on loss or gain of electron. Loss of gain of electron. Loss or gain of electron. Other ones here, we'll look at it as we move on. Loss or gain of electrons. So I've defined it before when we were talking about electrolysis. Those who were with us then should be able to identify this. So always tell the students they can use this acronym to define that. Oil weak. Oxidation is loss of electron. Reduction is gain of electron. So that defines that. Oxidation is loss of electron. Reduction is gain of electron.
oil rig. That's
Yes,
good.
oil rig. So oil rig. Taking? Can I continue? Okay, now let's move on quickly to oxidation number. Oxidation number. Oxidation number. So after this, then maybe we can now look at how to balance a Redox equation and maybe test for using an oxidizing agent. Oxidation number. So because the persons I'm lecturing or we are doing here now are not you people are already familiar with it. So what we all look at here now is calculating oxidation number. How do we calculate oxidation number? In calculating oxidation number, there are rules that must be followed in calculating oxidation number. There are rules for calculating oxidation number. However, I've never seen question. Hey, please, there's that noise coming. I've never seen any where students are asked to write out the rules for calculating oxidation number. But it is necessary for them to know the rules so that they can apply it when solving. And what are the rules? The first one is that the algebraic sum of a compound in its neutral state is always 0.
Yes.
The algebraic sum of a compound in its neutral state is always 0. Take, for example, I have maybe CuSO4. What are the component elements here?
Copper, sulfur, and oxygen.
Good. There are 3 elements here. Since there is no plus or minus here, the oxidation number of copper plus oxidation number of sulfur plus the oxidation number of oxygen all equal to 0. That is what that rule states.
Okay.
Is that taking place?
Noted, sir.
Okay. Then another is that the oxidation number of maybe atoms or group of atoms or radicals is always equal to the charge it carries. For example, oxidation number of SO4, 2 minus. Now, there are 2 elements here, sulfur and oxygen. In this case,
yes,
what I will do is oxidation number of sulfur plus oxidation number of oxygen times 4 all equals to -2 because of this that you are seeing up here. Not equal to 0 this time around. Is that taken?
Yes, sir.
Yeah.
Okay. If assuming this was plus, it will be equal to +2. Any sign you see here equals to that. It's as simple as that. Then also, the oxidation number of elements in group 1. Oxidation number of elements in group 1 is +1. All group 1 elements has the oxidation number as +1. Group 2 as +2. Group 7 as -1. And group 6 as -2. Can I come again with that? Or did you get that? Oxidation number of elements in group 1 is +1, group 2 +2, group 7 -1, group 6 -2, then group 3 +1. Sorry, +3 rather, +3. Then one more again, oxidation number of free elements is always 0. Oxidation number of a free element is always 0. Say, for example, I have Cl2. Oxidation number is 0 because it's a free element. It is not combined. Is that taken?
Yes, sir.
Okay. Then oxidation number of hydrogen or oxygen rather. Oxidation number of oxygen is always -2 with the exception of peroxides. With the exception of peroxides, say for example, hydrogen peroxide, oxidation number of oxygen there will not be -2. Is that, can I move on now? So we can look at some examples on how to.
Yes, sir.
Okay. So let's see one question here. It said, calculate the oxidation number of X in, oxidation number of X in SO4 3-. Calculate the oxidation number of X in this compound. So what I'll be doing now is we'll look at oxidation number, how to calculate it, and we'll now link it to IUPAC nomenclature. So that the student can know how to name compounds. Can I continue? Now we're asked to look
Yes,
for the number of X here. We already know the drill. There are 2 elements here. So that will be oxidation number of X plus oxidation number of O, which is oxygen. How many atoms of oxygen do you have here? 4. So that will be times 4, all equals to -3. So since we are looking for oxidation number of X, I'll leave it as X plus bracket. Oxygen is always -2. So that'll be -2 times 4, all equals to -3. -2 times 4 give me -8. Plus times minus gives me minus. So that'll be X minus 8 equals to -3. S equals to -3 plus 8, which will give me +5. Always let the students write the sign. If it's an objective question, you will see +5, you will see -5. Is that taking place? So let's see.
Yes.
Okay. Can I continue with another example?
Yes, sir.
Okay, let's look at another one. What is the oxidation number of chromium in K2CrO4? K2, can I claim this one? What is the oxidation number of chromium? Chromium is Cr. Oxidation number of chromium in this compound. So there are 3 elements there. K, what is the oxidation number of K? Can anybody try? Oxidation number of K, which is your potassium.
It's 1 now.
Okay, 1. Why is this so, please, sir?
In a very simple, just have one valence electron.
Okay, we'll add 1 valence electron, or simply put.
It has 1 valence electron. I think that is what I usually use.
Okay.
1 valence electron, and it belongs to group 1.
Oh, thank you very much. That's just the perfect answer. It belongs to group 1. So that will be 1 times 2, because there are 2 potassium there, plus Cr plus -2 times 4, all equals to 0. Not equal to, because there's no charge here. So that will be 2 plus Cr minus 8 equals to 0. Cr equals to 8 minus 2, which will give me 6. Is that taking place?
Yes.
Okay. So position number of Cr in this compound is +6. Now, like I said, let us link it to IUPAC nomenclature. You know the meaning of IUPAC? I'm sure we know this already.
International Union. Okay.
Pure applied chemistry.
Is it chemistry or chemist?
Chemistry.
Okay, chemistry. Okay. They are responsible for naming compounds. That's one of their functions.
Yes.
So they name compounds, either organic or inorganic compounds. So this is it an organic or inorganic compound? This compound.
It's an inorganic compound.
Okay. So this inorganic compound has how many elements?
3 elements.
Good. So when we have 3 elements, let the student know. You name 1, 2,
Yes.
3, then with the
3.
attachment of the oxidation number to it. So if it's 2, if for example, just like maybe I have PO4, 2 minus, I will name 1, 2. That correct?
Yes.
Yes.
1, 2, like is it correct?
Yes.
No. 1, 2. The other way around. So if it's 2,
Tetraoxophosphate.
you name 1, 2, not the name from the, this is my right, left. If it's just 2.
Okay. Yes.
So if it's 3, 1, 2, the middle.
Tetraoxophosphate. Okay.
Yes.
It's clear now.
Okay. So now let's come back here now. K is potassium. That would be potassium.
Potassium. Yes.
Then we are naming
Tetraoxo.
Good. Tetraoxo.
Chromate. Hey, is dichrome? Okay.
Chromate.
Chromate 6.
It won't be dichromate because there's no 2 here.
Yes, there's no 2.
Yes. So this is the name, because sometimes you can give them a question and ask them what is the IUPAC name. I've seen it in one of the jam questions here. So let them know.
Potassium.
So let's look at another example here.
Tetrachromate 6.
Yes.
Okay.
I have PO43 minus. So what is the oxidation number of phosphorus in this compound? Please, can we solve it and just let me know the answer?
Okay. That's my paper, my biro. PO4, yes, minus 3. Okay, P now plus minus 2 times 4.
Are we true? Then
It's
let's
5 plus 5.
MnCl2, MnO2, MnO4 minus. Plus 5, is it plus 5? You have plus 5?
Yes, it's plus 5.
Okay, plus 5. It's very simple. 2 times 4, 8. 8 minus 3, 5. Yeah, it's as simple as that. So that's now the IUPAC name is called what now?
It is now tetra ortho phosphate 5.
Something is still missing. One more thing to the name.
Ion.
Also phosphate 5 ion because of this.
Ion, yes.
And so don't just
Yes, 5 ion. Yes, you are right.
Okay, thank you. So for this one, can we just solve this now? Position number of M
Okay.
in the underlined ones. I've already underlined it. So in each of them.
Okay.
Madam, no be your face now.
I can't see anyone because my laptop is off.
Okay, let me just
my
repeat.
phone.
MnCl2, MnCl2, MnO2, MnO4 with a minus up. We are looking for oxidation number of manganese in all of them. That is Mn. Are we ready?
For the first one.
Yes, for the first one.
Okay. I got plus 2.
Okay. Plus 2.
The other one is, as in the next one is
Yes.
4.
Plus 4 or minus 4?
Minus 4.
Plus
Sorry, plus 4.
Plus 4, yes. And then the last one.
Okay. Should be plus 8 if I'm not missing words.
MnO4 with a minus up.
Okay, there's a minus up. Okay, I've not seen it. Okay. Then it's plus 7 if I'm not missing words.
Okay, plus 7, that would be correct. Yeah, that's
Yes.
4, 8 minus 1, 7.
Yes, it's plus 8 minus 1.
These are just simple.
Jesus. Hey, my husband will finish me.
Please, don't let him finish you.
I just messed up something now.
Please,
God.
I beg. Tell him I'm begging on your behalf. Okay. So, trying to see one question from white question here before we go on. I saw it and now I can't find it again. I just said, okay. Cr2O7 2 minus oxidation number of Cr here. So let's try this as well before we can go to something else. oxidation number of Cr in this particular one? Cr to
Plus 7.
sorry?
Plus 7.
Plus 7.
Chromium, okay.
Yes.
It's not plus 7. It's plus 7 now.
2 times 7 is 14. 14 minus 2, 12. 12 divided by 2, 6. Answer
It
is,
is -2.
answer is plus 6, sir. Cr2O7 with
Sorry.
minus 1.
Yeah, plus 6.
Yeah, so this is plus 6. Okay. So what will be the IU part name? IU part name?
Heptaoxodichromate 6.
Heptaoxodichromate 6 ion.
Heptaoxo, yes.
Okay.
Hepta ion, yes.
Yes. Okay. So I have a question here. I'm trying to pick it out. Okay. Because of space, it's supposed to be together as one. Yeah, that's why I'm writing it this way. So just pardon me. All supposed to be 2Cr 3 plus 3I2 plus 7H2O. The question is the change in the oxidation number of oxygen in the equation is the change in the oxidation number of oxygen in the question is. Are we there? The change in the oxidation number of oxygen in the equation above is, options are 0, 1, 2, 7. Is it difficult? The change in the oxidation number of oxygen in this compound is 0, 1, 2, and 7. Those are the options. It's a jam question.
It's really jamming.
Yeah, and it's really jamming.
Yeah.
Okay. So the change in oxidation number of oxygen in this question. Now, this is how questions will come in form of jam.
Change in oxidation number of oxygen.
Yes. In the equation above
Okay.
is, this is the equation already. So what is the change in the oxidation number? I've just, okay, I still have 4 minutes to round up this. Then we can now look at balancing Redox equation. Now, the change in the oxidation number here is 0. How do I arrive at that? Water is always 0. So this, your water here, oxidation number here is 0.
Here is -2.
So it is 0. Now, let me now add one more. I think it's still the same equation, but I'll just change it a bit now. Mr. Obi, are you with us?
That's why, because my laptop is off.
Sorry.
I don't have lights. I
Sorry.
need to on gen, but I don't want to on gen.
Now, obviously,
I can't fund that.
I understand. Okay, let's look at this. So in the above equation, or in the above, chromium changes from dash to dash. In the above, chromium changes from dash to dash. Option A is +7 to +3. B, +6 to +3. C, +5 to +3. And D, -2 to +3. In the above equation, chromium changes from, so that means we have to look for the oxidation change, the change in oxidation number of chromium in this compound. Then also find that of chromium and tell us what is it changing for. So, are you with me, please?
Yeah.
Okay. So can anybody try? In the above, chromium changes from V +7 to +3, +6 to +3, +5 to +3, -2 to +3. This is another jam question.
Chromium is +6 there now.
Yeah.
So it's from +6 to +3 now.
Okay, +6 to +3. So this one now is not jamming. This one is a straightforward answer. So
Yes, it's from +6 to +3.
so good. So that is just that. So questions under oscillation number can come in this form, either to calculate the oscillation number, or they could be asked, what is the change oscillation number in the above equation, just like we have done. Any question on this? Because the time is up. So maybe we can just quickly come back and look at balancing Redox equation.
Yes, that balancing is the most important part.
So we will come back and balance Redox equation, very simple aspect when we come back. Can I shut down now so we can come back again? As usual, it will take me 10 minutes because my updated version takes 10 minutes to come back up again. So please, you can just use the few 10 minutes break, stretch your legs, and then attend to one or two issues. Attend to your husband as well, so that your husband will not kill you, madam. So. So I think that will end now, so we can come back for balancing Redox equation.